multiplying rational expressions. All right, a rational expression is a fraction where both the numerator and denominator are polynomial expressions. When you have rational expressions, you always need to remember that if you have x's in the denominator and the bottom, then there are restrictions. Okay? So for more on these restrictions, watch my video, Rational Expressions Restrictions. If you are given a rational expression, you always find the restrictions before you simplify. That's before you multiply in this case, okay? Even if we divide, add, or subtract, which are other videos, we need to find those beforehand. However, for the purposes of this video, I'm not going to find the restrictions, but understand they exist. In fact, I believe they exist on every problem that we're going to do in this video. But I have a separate video for finding those restrictions, okay? So, but they do exist in these. I'm just trying to keep these as short as I possibly can. Some of them are still getting pretty long. All right. How do you multiply two rational expressions? Well, you're simply multiplying two fractions, so you multiply straight across, meaning you multiply the numerators, that's the tops together, and then you multiply the denominators together. The added challenge here is that they're polynomials, so it's the factoring piece. Right? That can take many, many forms. And in fact, any way that you have learned how to factor or are supposed to know how to factor in your math background, your whole math life is fair game. All right? So any way to factor is fair game. You just got to be careful and you got to factor it. All right? And so here, instead of actually multiplying, we'll talk about what we're going to do here. So if you recall, A over B times C over D, I'm sorry, I had the wrong thing selected there. A over C is A times C, and then B over D is B times D, right? I'm sorry, C over D. A over B times C over D. A times C, B times D. Multiply across the numerator and denominator. But that's what we do with numbers. In polynomials, we're actually going to factor each one of these individual things, okay? We're going to factor each one of these individual things. But I say this to say that, hey, A and D can divide out because they're now part of the same fraction, okay? C and B, same thing. So when you multiply two rational expressions, any factor in the numerator, that's the top, can divide out with any factor in the denominator, that's the bottom. So you simply factor and divide out common factors just like when we simplified, except now we have more polynomials potentially to factor because when we simplified them in the simplified video, we just had one fraction. We just factor, and then divide out. But here we have four things to factor, all four of these things to factor. And once we do that, then we divide out. But it's the same principle, and it's because you multiply straight across. Okay? Now, this is a Mr. Guestism here. This is the preference that I have. Not every teacher likes this. So look, if you're in a class and your teacher wants you to multiply out things and not leave it factored, you do what they want. Okay? I prefer to leave both the numerator and denominator, the top and the bottom factored, because this says to anybody that looks at my final answer, hey, I know what's up. I know nothing else divides out. Okay? That's why I do it, and I ask my students to do that. I need to see it factored at least at some point so I know they didn't just guess or just didn't even realize it factored and got it right. I need them to show me factored form, and that way I know they know it doesn't divide out. So here, if I look at this one, we have a fraction times a fraction, right? A fraction times a fraction. I know it's times because of this right here. That's a recognition piece. I have two rational expressions, fancy word for fraction, times each other. All right, so then I go through my little mental check. What I like to do is take each numerator, denominator, each fraction, and say, does this right here factor? No, because I'm gonna need to factor, and factor. Okay, factor everything, and then mark out, divide out common factors here, eliminate common factors. So can I factor the x? No. So I'm going to come over here in my first fraction and I have x. Can I factor 5? No. So it's going to stay in my denominator of my first fraction. Then times, can I factor 40? The answer is no, I cannot factor 40 as well. Cannot factor 40. And then can I factor x minus 8? No, I cannot. So we bring over here x minus 8. All right, so nothing factored. That's okay. Again, that's my mental check. I go through each one of these numerator, denominator, and bring them over if I need to, whatnot, to make sure that I have factored everything that will factor. And then after I get everything factored, in this case it already was, then I divide out common factors. So if I look here, and I usually work my way across the numerator to the top. So I start here, x, and I say, does x divide out with 5? Nope. What about with x minus 8? Now be careful, this is two terms. Can I divide out one term here of two terms? Nope, can't do it. So nothing divides out with that x. Then I say, okay, does anything divide out with the 40? Well, yeah, look, the 5. 5 and 40 have what in common? They have a 5 in common. How many times will 5 go into 40? 8 times, right? How many times will 5 go into 5? 1 time. So then I come over here and say, okay, what's left over? Well, I have an x and I have an 8. So this is 8x, and then I have 1 times anything is anything. That's x minus 8. So x minus 8. This is my final answer. Now, I want to talk to you a little bit about this fraction here. Notice I have a horizontal fraction line here, right? And there's no doubt that the 8x is in the top, the numerator, and the x minus 8 is in the denominator. So if you wanted to say, Mr. Gus, there's parentheses around this. That's right. There's parentheses around this and this. They're all understood parentheses when it's a horizontal fraction. This is also understood to be in parentheses. The entire fraction is. So it's best to write horizontal parentheses, and what I mean is, let me talk to you a little bit about slanted fractions that I see a lot of people writing. So what I tell my students, if you write slanted fractions, don't. That sounds blunt, and you might say that's rude, whatever, it's not rude. Okay, so here, just for example, this one, if you did this, and I know some people argue that this is all on the same line and it's understood. No. Order of operations says divide and then subtract. Okay? So what you really wrote down, if you write this down, is 8x over x minus 8, and that's not what you meant. So if you don't put parentheses on this, it's wrong. It's incorrect. If I don't do it, I'm wrong. I'm not holding me to a different standard than you or anything else. If it doesn't matter who does it, if I don't do it, you don't do it, it's not right. So we don't want to do that. So if you write slanted fractions, my advice to you is stop. The reason being, it's okay to write a slanted fraction sometimes. It is. And it's not wrong. However, a lot of times in math, when something is okay sometimes and not other times, then when you're an expert at math like I am, I've taught math for over 2 decades, I do math all the time, I know when it's okay and when it's not. But when I was trying to learn it for the first time, it was confusing. Well, why can I do this here and I can't do that here? So I like to avoid those things if I can, and one of the ways to avoid that is just don't ever write a slanted fraction. There's no need. So you never doubt what's in the top of my fraction or what's in the bottom of my fraction. If you put parentheses on here, that's okay. It's overkill here, but you can do that. So my final answer is 8x over x minus 8. All right? And the other big thing is here, you cannot cross these x's out because there's 2 terms right there. Okay? No. Okay? X minus 8 is all its unique factor. It does not have anything in common with x or 8 or negative 8. Okay? So then on the next one, same thing. I got the 12y plus 21, right? And I'm going to factor that. I got to factor this one. I got to factor this one. I got to factor this one. And I got to multiply again. Right? There's that dot. So when I multiply, remember, I'm factoring everything, and then anything in the top, the numerator, can divide out with anything in the denominator because we multiply straight across. All right? So here, I'm going to take this one in purple. Oops. I'll take this one in purple, and I'm going to factor this 12y plus 21. So come down here and say, okay, it's going to be something times another fraction maybe. So here, if I have 2 terms, there's only 3 ways that can factor. That can either be a GCF, because that's always what you look for first when you factor, anything in common, a common factor. It can be difference of squares, and it can be what I call SOPs, which is a sum or difference of cubes. So it can be one of those 3 things. If I look at this, do 12 and 21 have anything in common? And I don't ask myself the why because there's no y in this term right here. So yes, 12 and 21 have a what in common? A 3. So if I factor a 3 out, what's left over? Well, 12y divided by 3 is 4y, right? Dividing it out when I factor it out. Plus, if I take a 3 out of 21, divide it out, I'm left with 7. So then the next one underneath it here, the denominator here, I'm going to take it in orange. Is there anything in common with y squared and negative 3y? Yes, a y, right? If I take a y out, I'm left with y minus 3. And then I go to the next one here. And this one, y minus 3. Anything in common or anything in common with those 2 terms? Nope. Is it difference of squares? Nope. Is it SOPs? Nope. It doesn't have any powers. It can't be those things. So we just leave it y minus 3. And if you wanted to put that in parentheses, you can, but it's understood because it's a horizontal fraction. It's not understood in parentheses when it's a slanted fraction. It's understood when it's a horizontal fraction. All right, and then let's see. I'm going backwards in my colors here, so I'm confusing myself. So this one here, 4y plus 7, 4y plus 7. Again, nothing in common with the 2 terms. It's not difference of squares. It's not SOPs. Right, if I look, what's in common here? Nothing. Is it difference of squares? No. Is it SOPs, sum or difference of cubes? No. So then it doesn't factor anymore. So then I look and say, okay, what do I do here? Well, is there anything that divides out with this 3 down here? And remember, this is 2 terms, so you cannot cross those 3's out. There's nothing, so the 3 stays. What about 4y plus 7? It's gone, right? Remember, that's understood to be in parentheses, so those things are identical. And then the next thing in the numerator as I work my way across is what? y minus 3 right here. It's understood to be in parentheses, and that's exactly what this is. So guess what? It also divides out, and I'm simply left with what? I'm left with 3 over y. 3 over y. So then in my answer box, I have 3 over y. What am I doing on this problem? Times. I'm multiplying. Yes, I am multiplying. So if I multiply, then I'm going to factor each one of these things. So factor this one in yellow. So this is going to be list method, factors of 6, 1 and 6, or 2 and 3, that add to give me 5. Be careful. 6 minus 1 is 5, but it's 2 plus 3 here. So you have m and 2 and 3. And then they're both positive, right? If you have trouble factoring this, go watch my list method video. It will help you tremendously if you have trouble factoring, okay? Been doing this math thing teaching math for over 2 decades, and I tutored it for about 10 years before that. So this list method is the best thing I've ever seen. Okay, you may not like it because people like different things, but it's the best thing I've ever found. So, and I actually created it from other things that other people used. So the pieces are parts of master teachers that I combined into one method. So then here, this is going to be 1 and 6 and 2 and 3. Or let me say this. I'd never seen it all combined in the way I do it. Maybe I didn't create it first, but I put it together from things that many, many master teachers taught me. All right, so then here I want factors of 6 to subtract to give me 1, 2, and 3. So m and 3 and 2, doesn't matter which order, I'm putting it in a different order on purpose here. So the subtract, or the different sign, so then the bigger number, this says bigger number gets a plus. Bigger number gets a plus. 3 is a plus, 2 is a minus. And then I'm going to come over here for the next one, and times the next one. It's going to be in brown here. That's 2 terms, no GCF. That's the difference of squares. Right, m plus 3 and m minus 3. Right, we got to recognize it as such. It is the difference of squares. And then this one here, list method again, 1 and 6 or 2 and 3. Factors of 6 is subtract to give me 1. That's 2 and 3. So m and 3 and m and 2, and it doesn't matter what order you put them in. But the bigger number this time gets a negative. Notice it's almost the same thing as what I did in green. This was bigger numbers positive. This is bigger numbers negative. That's the difference. Okay? So 3 this time is negative and 2 is positive. And then I start asking myself, does it stay or does it go? All right? M plus 2, gone. Right? It's gone because it's in both places. So it divides out. M plus 3, gone. Gone. There it is, gone. M plus 3. Wait a minute. I already used it. I can't make it go out with this one. I already used it. So there's not another one. So that one stays. M minus 3 is gone. Okay? So I'm left with m plus 3. That's this one because it didn't have another m plus 3 to divide out. And then I am left with m minus 2. This one right here, right? So, and that cannot divide out. Those m's are part of multiple terms. You cannot divide them out or cross them out or anything like that. It won't work. M plus 3 over m minus 2. And then finally this one, and look at this one. This is a bad dude right here, okay? Times, this is times, and I have this one, wow, 3 terms, no GCF with a 3 in the front. All right, I call this bottoms up. So what I'm going to do is I'm going to come out here to the side. I'm going to factor this one. I'm actually going to use multiple colors to do this one, and that'll be what I bring back into my first fraction. So let me come back over here and have my first fraction and then times something else. So if I do this, I'm going to bring this over, and it's going to be, I'm going to take the 3 times the 16 and multiply it. So it's going to be x squared minus 22x minus 16 times 3 is 48. So the factors of 48, and I'm going to list them. You may can figure it out without listing all these out. But 1 and 48, 2 times 24, 3, 16, 4, 12, 6, and 8. And then we get back to 8 and 6. Okay, so it's already listed. I want the factors of 48 that subtract to give me 22. Well, look, 24 minus 2 is what? 22. So we come over here. Oops. That x goes in. I was trying to do equals. X and x. This is 24 and 2. And the bigger number gets a negative. That's what that says. Okay? 24 gets a negative, 2 gets a positive. And then I say, wait a minute. I'm going to divide by the 3 that I multiply by. This 3 is what gets divided by here, okay? So 24 over 3 is 8, and that's a 1. So that parenthesis becomes x minus 8. And what does the next one become? Well, 2 over 3 doesn't simplify, right? That doesn't simplify. So what I need to do is bring this 3, it's the bottoms up part. It comes back in front of the x, but inside the parentheses. So 3x plus 2, and I'm done factoring the numerator there, all right? So if I move then to the denominator right here, guess what? That's the same kind of deal. 3 terms, no GCF, not a 1 in the front. So I'm going to come over here and have another thought cloud. Have another thought cloud here. I'm going to take this 3 times this 10 here, okay? And that's going to give me x squared plus 17x plus 30. So basically I'm transforming that bottoms up into a list method, factoring it, and then transforming it back. All right, that's the process we're going through there. So here, the factors of 30, 1 and 30, 2 and 15, 3 and 10, 4 doesn't work, 5 and 6, and I'm back to 6 and 5. So I want the factors of 30 that add to give me 17. What are they? 15 and 2. So we're going to come over here and say x and 15 and x and 2. And both signs are positive. So plus and plus. And then I come in here and say, okay, divide both of these by what? 3, because that's what I multiply by, not because that's a magic number, because that's what I use there. Okay? So then 15 over 3 becomes a 5. So that parenthesis becomes x plus 5. I just realized I did not give myself room. So I'm going to have to fix that. All right, x plus 5. And then here, this does not simplify, so we're going to have to do what? Take the 3 and bring it up. It's going to be 3x plus 2, right? I so did not give myself room. So I need to move all this over. I'm just going to have to erase it and rewrite it, y'all. I'm sorry. So give me just a second here. So I got to give myself room here to do this. So in the blue, I had what? I had x minus 8 and 3x plus 2. Is that right? I want to make sure my fraction line is long enough, right? And then in the, what was it, yellow? I had x plus 5 and also 3x plus 2. And then I'm going to come over here and say, okay, I got to factor this one. That's 3 terms, right? There's 3 terms. There's a 1 in the front, no GCF, so that's list method. I want the factor to 48 to subtract to give me 8. So I have 1 and 48. So if this works, by the way, it's going to be x and x. 1 and 48, 2 and 24. I think I just saw these, didn't I? 3 and 16, 4 and 12, 6 and 8. Do I have any factors of that subtract to give me 8? How about 12 and 4, right? 12 minus 4 is 8. And then the bigger number's negative. The bigger number is negative, so 12 is negative, 4 is positive. And then I'm going to do this one here. Again, it's list method because it's 3 terms, no GCF. There's a 1 in the front, write a 1 out here, no GCF. So I want the factors of 32. So if it works, it's going to be x and x. I want the factors of 32. So let's list those down here. 1 and 32. I didn't give myself a lot of space here. Poor board presentation, forgive me. 4 and 8, and I think that's all of them. The ones that subtract to give me, right, subtract to give me 4. What are they? They're 8 and 4, right? So put in here 8 and 4, 4 and 8. It doesn't matter. Then bigger number's negative. So which one's bigger here? 8's negative and 4 is positive. And then I start asking myself, does it stay or does it go? X minus 8, gone, right? Gone. Like yesterday, it's gone. And then 3x plus 2, there it is above each other. It's gone. X minus 12, there's not another one. It stays. X plus 4, it's gone, right? So get rid of those. So that's everything that's gone. What's left? Well, I'm left with x minus 12 in the numerator at the top. And what am I left with in the bottom? X plus 5. Anything else? That's it, I think. Can I factor those x's out or do anything or divide out? Nope, can't do anything. So that problem is done. You can't do anything else. And I only have 12 colors. I used all of them on this problem, so it's my Skittles Taste the Rainbow problem for the day, and it was our last one. So I hope this helped you with multiplying these. We did have some different ways to factor on here. We had difference of squares, list method, bottoms up, GCF. I didn't do grouping or SOPs, which is sum or difference of cubes in this video, but they are other ways to factor as well.